is Carlos Barron, and I'm in PAF 503. We'll be going over Pearson's R in Excel as well as linear regression. I think it's important to establish what Pearson R is first, just so we have a good idea of what we're expecting today. And I want to go ahead and go over the most common measure of correlation, which is Pearson's R. So first things first, what is Pearson's R? It's actually the measure of the strength of the relationship between the independent and dependent variable. So as you see in our example right here, I have the two variables, which is age and average heart rate here. And I'm going to go explain whether or not there's actually a correlation between age and average heart rate. Even though we know there is one, we're going to go ahead and verify that using Pearson's R. So this is our way to know if the variables we are actually measuring are related and how much they are influence one another in general. It measures the strength of the linear relationship between the two variables. So things that we want to identify throughout Pearson's are, first, we want to establish whether or not there is a relationship. Second, we want to see if the relationship is strong or weak. And third, we want to identify the direction that it goes in. And the way we do this, we identify this by establishing the coefficient R and where it lies between the values -1 to 0 and 0 to 1. And we describe the relationship between the two continuous variables. And so what we are looking for today is when we conduct Pearson's R using Excel, we're going to look at the R value. If the R value is near 0 or equal to 0, there's no relationship at all. If the R value is at +1 or close to +1, there's actually going to be a strong positive relationship. And then for the next one, if it's close to -1, it's going to be a strong negative relationship. The stronger the relationship, the stronger the association between the two variables. And so in our attempts today, let's go ahead and solve for Pearson's R using Excel. So the first thing we want to go ahead and make is the formula to do so. And so what you actually want to do is type in equals. I'm just going to tell Excel that we're trying to command it to do something, and the action that's going to come in right after is Pierson. So I'd go ahead and type in Pierson, select Pierson. Let's give us array 1 and array 2. And so array 1 is going to go ahead and be your first column of information under age. Hit that. That does populate right there. Go ahead and hit comma sign. And if you can actually highlight that next one right there, that's next array, and hit equals. And so our Pearson R value that we have is going to be 0.88. Notice how the value does not have a negative sign in front of it, so therefore it is positive. And utilizing that, it's close to 1. The closer that it is to 1, the stronger the relationship that it has. It's above that 0.5 area that allows us to see whether or not it is strong or negative. And so we can establish that it is strong today. On the next example today, I'm going to go ahead and have you guys calculate the Pearson's R for this. So if you guys actually want to pause your video, I'm going to go ahead and give you some time to plug in the information today and work through this problem if you can, please. But what we're looking for, just so I can talk to you guys while you guys are plugging this information is whether or not there's a relationship for ASU students, have 10 students, whether the consumption of beers per week actually affects the body percent fat based upon my sample population for AAC students here. And so we'll give you some time to go ahead and calculate that. Okay, so now you have everything calculated. Hopefully you did have the chance to find your Pearson R value. And so we're going to do the same thing again, just in case you did forget. You want to put in the equal sign. Type in Pierson. Array 1, which is that first column, the beers per week. Highlight that. Hit a comma, as you see right there. Go to the next column over for percent of body fat for array number 2. Equals, and you should have gotten a value of 0.93. Again, do note there is no negative sign in front of it, therefore it is a positive correlation. Direction is positive. There's a strong correlation, strong relationship between the values because it is close to that 1 value. So the closer it is to 1, like I said earlier, would dictate that it is a strong positive relationship for this. And so the next thing we're going to establish is the linear regression for this, to find out where it actually lies on a scattered plot and what the linear regression is and where it crosses that y-axis. So let's go ahead and take the same example that we had earlier, identify what that is for us today. And so just recall it was positive, it was strong, a strong relationship in general. So there is a correlation between the age and the average heart rate overall. And we're going to go ahead and utilize this information here to kind of create that plot just so we can see it together and predict future outcomes from now on. And so we're going to collect this data. You're going to head on to the chart section. So I'm going to go through this slowly just so you know exactly what you're getting into. And before we jump right into this, let's go ahead and explain linear regression just a little bit more. And so linear regression, it's actually going to be the most basic and commonly way to create a prediction analysis with the information that we have in front of us. And the regression estimates are used to describe data and explain relationships between one dependent variable and one or more different independent variables. And so we want to utilize this information to see what our predictions will be from now on. And all right, so let's go ahead and highlight that data. Head to charts, like I said earlier. Go to scatter. All right, marked scatter. And let's go ahead and move the chart right to the side here. Let's get rid of this series so we have a little more room there. And just so by eyeing the chart here, we can see that it's positive. It's heading from bottom left here all the way to the right, indicating that it is in a positive direction here. And the way we solve this, we actually click on one point. But before we click on that one point, the linear regression sign, it's actually going to go ahead and create a line between all this data, indicating exactly where it sits. And it's not all the way to exact, but it is close enough as it's going to get as far as error room that is left over there. But what you want to indicate is where that line lies on the scatter point chart here. So we're going to click on one of these points here. And we're going to want to add a trend line and make sure it is a linear trend line. And we're going to go to options and go to display equation chart and display R value on the chart itself. And that's going to go ahead and let us know exactly what the linear regression line is. Okay, and so we see it populate there. We see the line there. Let's go ahead and move this over so we can better see everything on here. And let's go ahead and, excuse me, let's go ahead and highlight this for you guys so you guys can see it a lot better. And so this is going to be our y equals alpha x plus beta. And so the important thing about here is we're going to find out where y is a function of x. So we want to see where we input an x, so an age there, multiply by the 1.0, the 1 beer week, and I mean not the 1 beer, excuse me, the age there, and you add 31.24, and that gives us our new predictions from now on for whatever variable that we are inputting there. When you guys check out the r squared there, we do notice that it falls close to that 1 still, so there is still a strong positive relationship there. And we'll notice the line there, how it sits right between all that data information. And if we extend that line out, we'll see where it crosses that x-axis as well. But this also lets you know where it crosses that y-axis, not the x-axis, the y-axis, excuse me. All right, so for example number 2, again, we're going to go ahead and see if you're able to find the scatter points and find that linear regression line for yourself on this. So I'm going to go ahead and give you some time and let me know if you need any help. If anything does not make sense, please do leave comments at the bottom of the YouTube video so that we can go ahead and make it more efficient for us by correcting any mistakes that are on there or anything that seems unclear. All right, so should have had enough time by now to go ahead and use the scatter plot information. But again, reminder, make sure you're highlighting all that information there for number of beers per week and body percent fat there. And just as a reminder, what does that correlation tells us? Tells us that there's a strong positive correlation with that 0.934 between the numbers of beers that ASU students are drinking per week and the percent of body fat that they might have from drinking those beers a week. And so let's go ahead and find a linear regression now. So again, go to charts, scatter, mark scatter. All right. And then we can actually see where it crosses y-axis, but let's go ahead and I'm going to go ahead and estimate the line is going to pass right through there. But let's see what Excel tells us today. Linear, options, display on chart. And I'm going to go ahead and do it backward a little bit so we can see exactly where it crosses the y-axis. Interesting enough, huh? And looks like it crosses at that 3.75 there. Let's go ahead and make this big so you can see it. All right. And so we were fairly close to iron earlier, but like we said, that y is a function of x, and so whatever we get for x, whatever we're inputting in there, would go ahead and it would give us our predictions from now on as far as the number of beers that are drinking per week and the percent of body fat that would be the predicted outcome from now on. R squared is at 0.87, still letting us know that it's still a positive, strong correlation there. Hope this video was helpful. Thank you for watching today.